Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VIGNAna VJEC. I welcome you all to the lecture series on pavement materials. And the topic of discussion for today will be bitumen extraction test on asphalt mixtures. So this is the test what you are discussing today, that is nothing but bitumen extraction test. So the main aim of this test is nothing but to determine the binder content which is used in the preparation of asphalt mixtures. So we already looked at what is meant by Marshall method of mixer design, where we have prepared the Marshall mix with mineral aggregate adding some amount of bitumen. So in this test what we are doing is nothing but it is a reverse process where we are finding out the amount of bitumen that has been added to the mineral aggregate, that is nothing but to determine the bitumen content present in the asphalt mixtures. So that is what been mentioned over here, to determine the bitumen content in the bituminous mix by separating binder from aggregates. That is done by using a solvent. A solvent is something like any liquid like in which the bitumen is dissolvable. Here we have a solvent like trichloroethylene, benzene, toluene. Basically bitumen is nothing but hydrocarbon material which is obtained from the fractional distillation of crude oil. So it has the ability of dissolving in some of the solutions like trichloroethylene, benzene and toluene. Generally we do not encourage benzene because of health issues and all. So we generally go for using toluene. So you have to dissolve that bituminous mixtures, either the mix which is obtained from the field through core cutting process, that has to be broken into pieces and that has to be dissolved along with the solvent, or if it is a laboratory mix which is produced and that need to be dissolved in the solvent. So either ways you can do this test on the field mixes or the laboratory produced mixes. So it is mainly used for quality control along with mix verification and investigations on the field samples for research purpose. So it is not any test which is conducted before to accept that material, but it is basically a quality control test which is used for mix verification and investigations of the field samples. So quality control test may include like aggregate gradation check at plant along with the bitumen content by extraction test, field density and temperature monitoring during laying. So these are some tests which are used to conduct on quality control for quality control purpose. Similarly for mix verification purpose, we have to see that what is plant produced mix tested for Marshall properties. So we already discussed what is meant by Marshall properties, and we have to check these mixes for whether they are within the allowable limits of the Marshall properties. So that is basically a mix verification test. Along with binder content, same thing. The same test can be, estimation of binder content can be done for field control as well as mix verification. So this test can be done by basically two methods. One is nothing but centrifugal extraction test. You can do it, bitumen extraction. So in this you have to have this following apparatus. One is nothing but centrifugal extractor which is provided over here. So this is the centrifugal extractor, and you need to have a filter paper over here. So this is what the filter paper provided over here, and you need to have a solvent along with some weighing balance. Okay, so these are the components which you are supposed to have before conducting this test. So the process is like this, which is mentioned in brief. First, weigh the amount of bituminous mix sample. So you have to get the bituminous mix whatever is required on which you are supposed to conduct the bitumen extraction test. So I've got the sample which is obtained from the field after the service life of the pavement, which we basically called as RAP. That is nothing but I want to find out what is the bitumen content in this RAP mixture. So along with, and then you have to soak this bituminous mixture in the solvent for 24 hours. So you take this RAP mixture or any bituminous mixture which is immediately laid in the field. It can be done on any kind of bituminous mixture. So that need to be solved for 24 hours in the solvent. So that is nothing but the binder has to be completely dissolved in that solvent. So it need to be soaked in solvent for 24 hours. And after that, place this entire mixture along with the solvent in the extractor bowl with the filter paper. So I have got this components over here. So this is the extractor bowl which I brought along with me. And this extractor need to be kept in this cylindrical drum for extraction purpose, and rotate the bowl. So this bowl has to be rotated with some high speed for which is subjected to centrifugal force. Then that bitumen and solvent is expelled out of this drum at the same time, and add more solvent. You have to keep on adding more solvent to dissolve the bitumen if there is any amount of bitumen present over there. So repeat this process till the extract, whatever is the extract which is coming. So the liquid plus solvent, the bitumen plus solvent will be coming out of this exit pipe. So that solvent has to be appear completely like a this mixture has to be appear completely like a solvent, like toluene which you are using. So and then you have to dry the aggregate and determine the binder content. So I'll be explaining this with the help of the apparatus which I have brought along with me. So this is the bowl which I'm using over here. So this basically you have to take this asphalt mixture So this is I've got the wrap mixture. So I have to soak this for 24 hours in the solvent like toluene. So I have got this extractor bowl for demo purpose. So this is the bowl which is used for determining the bitumen content in the extraction test. So you need to take the required amount of bituminous mixture, so which is present over here. So that you have to soak that bituminous mixture in the solvent for 24 hours. And in the next day, while soaking that, you have to take a precaution that you need to cover that bowl which is in which you have soaked the bituminous mixture with the help of a paper, so that there won't be any amount of the solvent which is going to be evaporated. So because bitumen is also contains some amount of volatile, so that it gets evaporated and there will be misinterpretation of the results at the bitumen content what you are estimating. So as a result of that, you have to cover that soaked material with the help of the paper. And after that, next day after 24 hours, you have to transfer that entire bowl which is with the bituminous mixture along with the solvent. So that need to be transferred over here, and this need to be covered with the first thing is you have to cover this with the filter paper. So I have shown there along with the filter paper also, and this is the lid over here. So this lid is provided on the top of this. So I've kept inside the material the bituminous mixture along with the solvent which has been soaked for 24 hours, and I've covered with the lid. So and after then you have to provide this knob for tight purpose. So you have to tight this knob like this, and this entire apparatus will be transferred to this cylindrical drum which is present over here in the bitumen extraction apparatus. So that inside that there will be a scenario where there will be this entire bowl will be sitting on the shaft provided inside the cylindrical drum. And after that, once you started this experiment, once you start this apparatus, switch on this apparatus, then there will be some centrifugal force which will be generated, and this will be subjected to some revolutions like this. So as a result of that, the bitumen solvent along with solvent which has been soaked for 24 hours will be expelling from this, will be coming outside of this, and that will be coming through this exit pipe. So there will be this entire setup will be going inside this. So and then it will be coming outside of this, and it will be touching on the drum of the cylindrical drum over here, and that will be coming to the bottom of this drum, and that will be collected at the exit pipe. And that whatever the exit pipe you have collected, the liquid which is along with the solvent. So here there will be exit pipe where you can collect the mixture of the solvent along with the bitumen, and that need to be subjected to distillation purpose, process to collect the residual bitumen for further research investigations. So this is what I just again repeat the process. So there is a centrifugal extractor over here. The first one is the entire drum is nothing but the centrifugal extractor over here, and there is a filter paper which is covered on the top of this lid like this. You are placing the filter paper onto this after transferring the bituminous mixture along with the solvent, and then you place this lid over here on the top of this, and you provide the knob, you tight the knob, and this entire setup is completely shifted to this cylindrical drum, where that bowl will be rotating or will be rotating around the cylindrical shaft, a shaft which is rotating, and that will be subjected to centrifugal force. Then bitumen solvent plus solution is expelled. So this will be bitumen solvent will be expelling from this, and it will be touching on the surface of this cylindrical drum. That will be collected to the bottom of this drum, and it will be collected at the exit pipe. That can be used for research investigations by subjecting that to distillation. And after that, so whatever the aggregate which is present inside this, so after bitumen extraction, bitumen solvent has come outside, so there will be only aggregate which is present inside the bowl. So you have to take this bowl outside. So you have to take this bowl outside, and that bowl has to be, that material inside the bowl has to be transferred into some tray, and this has to be oven dried. So you have to oven dry this material, and then you take the weight of that aggregate. So then you'll come to know how to estimate the bitumen content. So this is the observation sheet. So observation sheet, this is the serial number. So this is the location of the sample. So I have got sample from one location. So the description of the sample is nothing but the first one is BC1 and the second one is DB1. DBM1. So the initial weight of the sample, you can go for determining the doing the extraction test for a weight of 500 grams in this centrifugal extraction test. So I've initially taken the loose mixture, whatever is this. So this kind of loose mixture which I've got it. So that I've taken for 500 grams. So the initial weight of the filter paper, these are the weights corresponding to the filter paper, because I provide the filter paper below the lid which is provided inside the bowl. So the initial weight of the filter paper is somewhere around, I have got it to be 3.8 grams. And after that, after the test is completed, there will be some amount of fines which will be attached to the bottom of the filter paper. So the entire filter paper weight along with the fines has become 4.7 grams. 4.7 grams. So once you determine the only retained weight of the fines attached to the filter paper. So this is the initial weight of the filter paper. This is final weight of the filter paper along with some fines. So I want to get the only retained weight of the fines. So this has come to be 0.9 grams. So that is what the weight of filter fines which is deposited on the surface of the filter paper. And this is the weight of the mineral aggregate which have got to be 473. So after the bitumen has been removed along with the solvent, so the weight of the mineral aggregate alone without the weight on the filter paper, it has to come to be 473. So the total weight of the mineral aggregate will be this plus this. So 473.9 grams. So totally initially I have taken 500 grams, out of which 0.9 grams have been deposited on the filter paper, and 473 is the mineral aggregate weight which has been obtained after oven drying from the aggregate. So and I have added both of them, which has come to be 473.9 grams. Then you have to go for using this small formula, which is nothing but initial weight minus final weight. So final weight is nothing but 473.9 divided by initial weight. Then you will come to know what is the amount of bitumen content, which is nothing but 5.22%. So it means nothing but they have used binder content of 5.22 in producing the bituminous mixture. So for BC1, so similarly you can go for estimating the bitumen content for whatever the mix you have got it. So I have got the values for DBM1 also. So again the same thing, I have got the weight of the bituminous mixture to be 500 grams, and the initial weight of the filter paper still is again 3.8 grams, and this is 5 grams. So the final weight is 5 grams. So therefore the amount of the fines which has been deposited on the filter paper is 1.2 grams, and the weight of the mineral aggregate is 477.2 grams. So you add both of them, so that has come to be, sorry, this is 476 grams. You add both of them, so it will be 477.2. So this is the total weight. And again initial weight minus final weight divided by initial weight. So it will come to be, so the bitumen content in this DBM case has come to be 4.56. So this is the easy way how do you determine the bitumen content in the bituminous mixture. So there is another test which you are going to use for bitumen extraction, that is nothing but Soxhlet extraction test. So here again the Soxhlet extractor. So this is the equipment, the apparatus which you will be using for determination of the bitumen content. So the first one is Soxhlet extractor. This is a Soxhlet extractor. Condenser. So this is the condensing unit which is present over here, and there will be heating mantle. Below this there will be a heating mantle which I will be showing in the next figure, and there is again solvent, either it might be toluene or benzene. So I've got some apparatus along with me. So this is the basically the Soxhlet extractor. So I have shown here Soxhlet extractor. So you have to take the bituminous loose mixture, but this in this experiment you need not to soak the loose mixture previously. Before itself you need not to soak this material. You have to take some amount of material, bituminous mixture, and that you need to place in a paper thimble. So that paper thimble along with the bituminous mixture will be placed inside this Soxhlet extractor, a Soxhlet glass tube. So that will be coming to the bottom of this. So whatever basically the amount of the material which you will be taking in this experiment is nothing but hardly 200 grams. So the 200 grams has to be placed into the paper thimble, and that has to be kept inside this Soxhlet tube. So that will be coming over here, and after that you need to connect this to condenser. So this is the condensing unit over here. So I'll show one by one. So this is basically Soxhlet tube. So that will be placing the mixture along, and then you will be adding bitumen content from the top of this. So you'll be adding bitumen content. You'll be adding solvent. So I'll show the condensing unit over here. So this will be connected. This bottom of this condensing unit will be connected to the top of this Soxhlet tube, and then you'll be adding initially the solvent over here. In this case I am adding toluene, so that will be coming here, that will be passing through the inside this thing, that will be passing over here. So that will be coming like this inside, and that will be falling onto this bituminous mixture which is present in the Soxhlet tube. So that gets dissolved for some point of time, and after that, so there is basically a heating unit present at the bottom of that. So in the first cycle, you have to add enough amount of solvent. So that is nothing but you have to keep on adding toluene from this, such that there will be toluene which is coming on the top of this, and by siphonic action, So whatever the toluene you are adding, that will be dissolving the bituminous mixture, and that will be coming out of the paper thimble. So because that is very soft, and the material, the solvent can be coming outside of the paper thimble, and that will be coming like this by siphonic action, and it will be rising like this up to the top of this, and it is coming again back in the reverse way, and that will be coming directly into that glass or conical flask which is provided at the bottom. Very simple. You have to keep on adding the solvent such that there will be a rise of the solvent along with the bitumen, and that will be coming and deposited to the bottom of the conical flask. That has to be repeated for one cycle, and after that you have to add another half of the solvent into this. You have to add another half of this, you have to add solvent up to the half of this tube. So another half will be coming from the bottom conical flask. So that conical flask will be heated. So because of that, there will be some vapors which is coming up. So you know that solvent gets evaporated. So that will be coming from this. So it will be coming like this and here, and it tries to evaporate from this inside. So when it is going from this inside, so that will be coming from the central portion, but where we are providing water entry here and water exit here, so that water which is provided over here, it try to condense the liquid or condense the solvent which is expelling out of this tube, and again as a result of that, once it condenses, it will be falling back into this Soxhlet tube. So that is why we are only adding half of the solvent in the second cycle. The other half solvent will be recovered, will be coming from the bituminous mixture, the bituminous solvent which is present in the conical flask. Only the solvent will be evaporated, and that will be reused again and again, again and again. So this is the operation of the Soxhlet extraction test. So I'll explain once again with the diagram present over here. So basically this is the bituminous mixture which I am having over here. So the one in green color. So there is a paper thimble. So this is the paper thimble. It means nothing but you are providing the entire mixture in the paper thimble. And after that you are adding the solvent like toluene from this unit inside. So that will be coming and falling onto this. So that will be again dissolving. So that entire bituminous mixture will be subjected to dissolving action. So and after that, so once it gets dissolved, you have to keep on adding the solvent until unless there will be a rise of the bitumen solvent up to the top of this, and it will be coming back into this conical flask. So that you have to do for one cycle. So you have to add that amount of solvent till that there will be one cycle which is happening over here. And after that, so you make sure that you don't add the solvent up to the full for the next cycle. So you add only the bitumen solvent, so the solvent only to half of this glass tube, and after that there will be already the solvent which is nothing but here mixture of bitumen plus toluene, there will be present over here. So once you start heating that, there will be only the solvent which is nothing but the toluene which is coming like this, which is evaporating like this, and it will tries to enter this portion, and it will try to go upwards. It is trying to go upwards, but you are providing the water inlet. So that water inlet, the water which is entering inside will be condensing this solvent. So that will be cooling this solvent, and as a result that solvent will not go outside, and it will be coming back and falling over here. So you have already added half, the other half will be coming from this solvent vapor. And again once this solvent vapor is coming enough quantity, so then there will be a rise of this again bitumen solvent that will be coming over here, and this is a repetition process. So it goes on for 4 to 5 cycles, such that whatever the bitumen solvent or the solvent which is coming from this this tube should be appearing as a pure toluene. So there should not be any traces of the bitumen. So then we can conclude that there is completely the extraction of the bitumen in the bituminous mixture. So this is what the operation of the Soxhlet extraction test. So this is the Soxhlet extractor. The bottom side, it is a Soxhlet extractor, and there will be the condensing, and there will be, you will be having a heating mantle over here, and there will be solvent. Of course you need to take the solvent. So in this place, weighed mix in the thimble, paper thimble inside the Soxhlet chamber. So I've told you the maximum weight that we can go for conducting this test is nothing but 200 grams of bituminous mixture that need to be kept in the Soxhlet chamber. Heat solvent in the flask, but before heating that, there is another one more step. You have to make sure that there will be one cycle operated by adding the required amount of solvent until the bitumen solvent is coming and collected at the bottom of the conical flask. And then after that you have to keep on heating the solvent in the flask, which is going to rise because of the vapors, and it goes outside like this, and as a result it get condenses, it will be coming back, and that itself will be used for the next cycle. So hot solvent repeatedly washes the sample. So whatever the hot solvent which is coming outside, and it is getting condensed, and it will be coming back, and that itself will be washing the entire bituminous mixture again and again, till that continue the cycles till the extraction appears completely clear, just like that of the towelin. So then you have to take this again, the material inside the paper thimble, you have to oven try the aggregate mixture, mineral aggregate, and you have to find out what is the amount of binder content. So this is the entire figure which is shown in a line diagram. So only thing is nothing but from the previous diagram there is an extra addition of this heating device over here. Otherwise it is similar to that of the previous figure. And there is again observation sheet which is similar to that of centrifugal sheet. So there is again a serial number, location of the sample, there is the description of the sample HDBC and dBm. So I have got only 200 grams of the bitumen. Here I have not taken the weight of the filter paper. So because initially I have taken the dry weight of the 200 grams after tearing. So I did not take into account the filter paper weight. So I've taken the loose mixture which is teared in condition 200 grams, and I've added that directly to the paper thimble. So I did not take along with the paper thimble. So and after that also I've woven dried the aggregate, and after that woven dried the aggregate, that mineral aggregate I have taken the weight without the filter paper. So I am not going to use this. If you are taking these weights along with the filter paper, you can add these weights. So I did not take that into consideration, and this weight which is coming is nothing but 189.2 mineral aggregate. So the total weight is also 189.2 because I did not use any weight which is retained on the fines. So therefore the weight of the mineral aggregate is 189.2 grams, and there is no weight over here, 0. So 0 plus 189.2 is still again 189.2. So then again you have to use the formula which is nothing but initial weight 200 grams minus final weight 189.2 divided by initial weight 200 grams. So the bitumen content in this case has appeared to be 5.46. So this is the bitumen content. I told you again the bitumen content is determined by two different ways. One is nothing but by weight of the mineral aggregate. So that is by weight of the mineral aggregate means x grams divided by 200 grams is equal to some 5.46. This is bitumen content by weight of the mineral aggregate. But if you want that to be by weight of the total mixture, so x divided by 200 plus x is equal to 5.46. So that is way how you will get the weight of the amount of the bitumen you need to be added. So this is one chart which is showing the differences between centrifugal apparatus and Soxhlet apparatus. The principle is nothing but this is operated, centrifugal apparatus is completely operated by means of centrifugal force, and this is reflex dissolution. And time required is very short time. You can complete the test in hardly 15 to 30 minutes. But before that you have to soak the liquid for 24 hours without any effort. So you have to soak the bituminous mixture for 24 hours. That can be done easily. And the test is only conducted for hardly 15 to 30 minutes. But this is a long test which is need to be conducted for 4 to 6 hours. But it doesn't require any prerequisite dissolving the, soaking the liquid, soaking the bituminous mixture. So accuracy will be moderate here. Why? Because the only reason is when you are the liquid bitumen solvent is washing, expelling outside of the centrifugal bowl. So there will be some amount of fines which are coming outside of this bowl. So as a result of that, there will be, some amount of the fines will be lost, and there will be misinterpretation of the weights. So but here the accuracy will be very, very high, because only from the filter paper there will be there will be no amount of fines that will be coming outside of the paper thimble. So solvent used is less, and here it is initially you have to use more. And heating required, there is no heating purpose in case of the centrifugal apparatus. You have to go for heating purpose in this case. And suitability is nothing but routine quality control and field labs. Basic test you can go ahead with the centrifugal extraction test. But whereas when you want to conduct some research investigations and you want to get the accurate values for representation, then you have to go with Soxhlet extraction, where you are going to get exact values of bitumen content. Research and detailed analysis you will be going with this test. And loss of fines is a possibility of loss of fines, as I told you previously, but there is approximately it can be negligible. You can tell it is almost nil, and the cost and complexity is very less, and this is higher in terms of the Soxhlet apparatus. So this is what after once you get the bitumen solvent. So there will be bitumen along with plus solvent. So you are having both of them, which is collected from the outside of the either centrifugal extractor or oxalate apparatus, you'll be having the liquid which is containing both, and that will be subjected to here. So that will be subjected to distillation here, and again the same process, you will be heating this and the vapors will be coming in this inclined position and you are cooling this. So as a result of that, the solvent will be coming and falling over here. So you can separate toluene. So the advantage of having this distillation and equipment is nothing but you can recover the toluene which is used. Approximately, if you are using 1 liter of toluene, you can approximately collect 800 ml of toluene. So that is what you can assure in this test because of the distillation, and as a result of that, the complete toluene is getting evaporated from this. So you will be left out with the only bitumen residue. So that is nothing but residual bitumen. So you'll be having residual bitumen. So if this is any field aged bitumen and you want to conduct any research studies on this binder, then you can use the binder for that research purpose. So this is the distillation purpose. So this is the flow chart. So initially I have taken the wrap material or any field mixture, whatever it is, field mix for bitumen extraction, that will be subjected to extraction. Either this is a centrifugal operation, this is a centrifugal operation, you can replace this with oxalate extraction also, oxalate, either ways you can do. And after that, the liquid which is coming from both of the test will be subjected to distillation purpose, and after that you will be having the bitumen like this. So that can be used for research purpose. And I have forgot to mention the test codes on the in the video of test on bitumen. So I have represented here, presented the test codes which are used for conducting the test on bitumen: penetration test IS 1203, softening point IS 1205, ductility 1208 IS. So this is IS. And absolute viscosity is IS 1206 part 2, and kinematic viscosity is also IS 1206 part 2. And the test what we have conducted so far, just now discussed what we have so far. So that is nothing but the bitumen extraction, which is done as per ASTM D2172. So that is the completion of the bitumen extraction test. So I sincerely acknowledge the use of publicly available resources that supported and enhanced the visual clarity of this presentation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.